yo, yo! Don't you know it's time to go over the practice test for my second period algebra homies.
Yeah, that was good.
Okay.
So dogs and stuff, yo.
It's time. It's time, Eric, to answer the questions, you know? Number one, when we have a congruent statement, we spend a day on this. We need corresponding parts in the same place. So L corresponds with M. M corresponds with M because they share M as a vertex. And P corresponds with O, and they are congruent. Same, these sides are the same, these sides are the same, these sides are the same, these angles are the same, and so on. So the answer is B. Number two, they are not congruent because if you look closely, this is 5.3, that's 6.1, so they're not congruent. I mean, missed that. Number three, again, what corresponds with C? G. So where are C and G in the same place? Here, not here. C and G, not there. C and G there. What about B? B corresponds with F. Oh, nope, has to be A. Okay, next one. Now this one, you have to understand, it's rotated. The corresponding parts are indicated right here. So Q corresponds with T. Okay? So TB corresponds with QS. Oh, how long is QS? 6? So is TB. Okay? Angle U corresponds with angle R, and R is 120, so it'll be 180 minus 120, which would be 60 because there's 180 degrees in a triangle. So 60. Okay, that was the first 5 points on the test. Hopefully you got all those right. How many lines of symmetry does a regular octagon have? 1, 2, 3, 4, 5, 6, 7, 8. No. I figured out 6. Oh, right. Okay. So the answer is 8. How many turns? Every 8th of a turn, it will be congruent. So what's 360 divided by 8?
45.
45. A lot of you got this wrong. You'll have to list them all out. Yeah. Okay. Does this have a line of symmetry? Whatever that, everything has 360, so yeah, you'll lose half a point for the 360. Okay. This has line symmetry right down the middle, that's it. One line. Okay, the next one, remember I said pretend that this is all solid, so we really are just looking at the rim design, okay? So, how many congruent sections are there? 5, that is 360 divided by 5, 72. So, first of all, are there any lines of symmetry? None or 0. What are the angles of rotation? 72, 144, 216, and 288. Yeah, I got that. Yeah, you should. Okay, just to remind you, I guess, okay, number 9. Find the coordinates of the vertices after rotation 90 degrees clockwise, graph the preimage in the image. So, this one at -7, 7, 1, -2, and 1, -2. Oh, I gotta lock that down. 1, -2. What's in here? Wow. Okay, try this again. That's right so far. All right, and then we have 2, 5. 2 5s, so we have A, B, C. We connect those with straight lines. I'm going to have to do some calibration here before we move on. That. I
didn't know your thing.
Okay, moving on. Let's continue this. Lauren says it's not by day. Maybe she is right. I don't know about that, but okay. So then, if we were to rotate it 90 degrees, what happens? Well, look at this, and we know that these are going to change, right? Okay, so for sake of time, we're going to actually go over these graphing problems under the document camera.
And we're back.
And we're back.
Only
All right, so now we're going to continue on with the rest of the problems that I didn't show you under the document camera. Graph this translation after it is moved 4 units right and 3 up, 4 right, 3 up, that's C prime, 4 right, 3 up, that is D prime, 4 right, 3 up, that is A prime. Connect those, and you get this. Of course, I'd use a ruler. And what is the translation? It is x plus 4. When we go right, 4 it's plus. And then 3 up would be y plus 2. Let's try that again. All right. Next one. This is a big standard for 8th grade, and that is being able to prove 2 figures are congruent by mapping one onto the other through a series of transformations. So I think the easiest way to do this is to call this point P. So I would rotate it 90 degrees, clockwise, rotate 90 degrees clockwise about point P, because then it would look like this. Then I would translate x minus 1. Then what would y be? If I went 1 left and I want to go 1, 2, 3, 4, 5 down, this is one of many ways. You might have a way that works too. Of course, you don't even have to do it in this order. And then I'm just doing what makes sense to me. So now it's going to be here when I apply that translation. And then I'm just going to reflect across what? What's that line? It's actually not the y-axis, it's across the line what? X equals -1. Because this line right here that I'm reflecting across is x equals -1. So that's one possible way. You may want to check the answer. Okay, so I had reflection. So if you do a reflection, you have to tell across where. Oh, I didn't say that. Okay, well this is just doing all the things that we learned. I figured you guys could do it. Just putting it all together. Okay, Allie? Well, yeah, now you know. I want you to be specific. Okay, so don't worry about it. I'm just treating you guys with the notion that I believe you guys can see this and know and learn and be ready to go to the You guys are fast learners, especially on stuff like this. And if you have questions. All right. How about this one here? These were supposed to be easy. All you had to do was multiply by the scale factor. So -3, -3, 9, -15, -9, 0, -21, -6. Same dealio here. That'd be -2, -1/4. That would be 1, -3/4. That'd be -1, 4, 7/4, or 1 3/4. And -1/2, -1/2. Yes, because it terminates, but be careful. Really no reason to. Okay, next one. We're looking at this dilation. Is it enlargement or reduction?
Let's do reduction.
Yeah, because the prime marks, so it's definitely a reduction. The scale factor. What is the width of the new image compared to the width of the old image?
The past that.
Half that. Okay. So this one was 2 units across. This is 1 unit across. So this is half of one. You can also use the coordinates in the world. Okay. What about this one here? This is a what? Glide. These ones are meant to be pretty easy. This is a flip or reflection. This is a turn. Nice. Okay. This is we're mapping these. Okay. So which one is right?
Okay, I was confused because I was like, black paper or whatever it's called, and I like put a point like right here, like that made a nice and I turned it and it made that.
Okay. So if you rotate and then slide that,
But I didn't have to find that.
there's no coordinate plane to know about which way you're going.
Yeah, but I like made it.
Don't overthink it. All right, 23. The figures are similar because a reflection, no. Rotation, no. Translation followed by dilation, yes. Okay. And that's that for that page. This one, it would be a reflection and a dilation. And then this one, it says the dashed line figure is a dilation of the solid line figure. So did this get bigger or smaller? Bigger by, and what's the scale factor? 3. Right? Because this is 2 units, and this is 12. Isn't that 12 units? Yeah, that's 12 units. 12 and 4. 12 over 4 is. Okay? Kind of hard to read on the screen here. And 26, this is a reduction. Okay? So this is how big compared to this. This one is 6 units. This one is 2, 4, 6, 8, 10, 12. So it would be reduction 1/2. And this is, again, kind of goes with that congruent, that problem where you had to do 3 transformations. So this one, ABC is reflected across the x-axis and translated, okay? Angle B has the same measure as angle B prime. Yep, when you go through a transformation, what's the only one that would change? Well, actually, would it change if it was similar? No, still be the same. So, that is true. Side AC is longer than A prime C prime? No. They're the same. So that's false. Side BC is the same length as B prime C prime? Yeah. Because when you transform it, it still stays the same. And that's just side length. Okay, last one, the bonus. Yeah, this is a bonus. I guess I didn't label it bonus, but it was. Okay, so, and the answer was what? A. Boom. Okay, so we need to find this distance right here, right? Okay, what do we know about these 2 triangles here? Yeah. These angles are congruent, these angles are congruent, so that angle must be congruent, so they are similar because all corresponding angles are congruent. So we could say 60 over 114 of this height over this height equals this hypotenuse over this hypotenuse. Cross product rule, 60b equals 105 times 114. 105 times 114, 11,970. Divide by 60, and what do you get? a number that is on there, which is this right here. So that means this distance from the dock to dock is linear. Okay. You guys feeling confident for tomorrow? Yeah. Okay, well, you know it's practice then. No, we're going to do transformation Jeopardy the rest of the period and practice. So, you want to elect a captain in each quad in between 1, 2, here's the 4. 1, 2, 3, 4, 5. Here's your 3, your team 6. And you want across the map for team 7. Huh? 1, 2, 3, 4, you're 5. So, one person from each group get a marker and a board. Marker and a board. Marker and a board. Okay.